In this video, I'll show you how to integrate trigonometric functions containing sine and cosine with odd powers. To tackle products of cosine and sine, you need to follow these steps, and we'll refer back to them as we complete each question. We'll start with question 1. In question 1, they want us to find the integral of sine to the power of 5x times the square root of cosine x. Since sine to the power of 5x has an odd power, we need to follow this first suggestion, which says that if one power is odd, you split up the odd power. So I'm going to split sine to the power of 5x into, and here's our new function, sine x times sine to the power of 4x times the square root of cosine x. Also, remember that the identity cosine squared x plus sine squared x is equal to 1 can be manipulated to look like this. Sine squared x is equal to 1 minus cosine squared x, where I brought this cosine squared x to the opposite side. And I can also manipulate sine to the power of 4x into sine to the power of 2x to the power of 2. So I end up with sine x sine squared x to the power of 2 times cosine x. Now, why am I doing that? Well, I can replace this with 1 minus cosine squared x, and then I can substitute u as cosine. Here's what I mean. The integral of sine x, and this now has become 1 minus cosine squared x to the power of 2 cosine x. My next step is to choose a u value, and what I'm going to choose is cosine. U is equal to cosine x, and I'm going to find the derivative of both sides, where I get du is equal to negative sine x dx. Solving for dx, I get dx is equal to du over negative sine x. I'm going to substitute this into our function, where I have the integral of sine x 1 minus u to the power of 2 to the power of 2. This has become the square root of u, and the dx is replaced with du over negative sine x. This cancels out. I'm going to take this negative outside of my integral. I'm allowed to do that, where I have the integral of 1 minus u to the power of 2 to the power of 2 times the square root of u. Furthermore, I will expand this part of the equation, where I have, and here's a little aside for you, 1 minus u to the power of 2 times 1 minus u to the power of 2. You end up with 1 minus u to the power of 2 minus u to the power of 2 minus u to the power of 4. And these combine to 1 minus 2 u to the power of 2 minus u to the power of 4. So I'm going to replace this part of the expression with this. Negative the square root of 1 minus 2u to the power of 2 minus u to the power of 4. And this I'm going to switch into fractional exponents, where I have u to the power of half. And I'm going to multiply it inwards using the distributive law. This gives me the integral of u to the power of half minus, and here's where it gets a little complicated, 2u to the power of 2 times u to the power of half. We have to use the product rule of exponents here, which says that if the bases are the same, you add the exponents. So 2 plus half is equal to 2.5, and that is equivalent to 2u to the power of 5 over 2. So 2u to the power of 5 over 2. And similarly, 4 plus half is 4.5, and 4.5 is the same thing as 9 over 2. So minus u to the power of 9 over 2. Now I can finally integrate each of these three terms, and that's not easy as well, because you have to add 1 to each of these exponents and then divide by that number. Adding 1 to half gives me 1.5, which is u to the power of 3 over 2 divided by 3 over 2, which is 2 and 3 as the denominator. Next, I have to add 1 to this, 1 plus 2.5 is equal to 3.5. So I have minus 2, and 3.5 as a fraction is equal to 7 over 2. Now if you don't know how to do that, you can use your calculator. U to the power of 7 over 2 times 2 over 7, and this becomes a 4 at the top. And lastly, adding 1 to 4.5 gives you 5.5. That as a fraction is 11 over 2. So 11 over 2, 2 over 11 plus c. Now, I have to substitute back what my u was originally. And my u originally was cosine x. So I have negative 2 times cosine x to the power of 3 over 2 over 3 plus 4 cosine x to the power of 7 over 2 over 7 and plus 2 cosine x, 11 over 2 over 11 plus minus c. This doesn't really matter at all. Anyway, that right there is the answer, or the integral, of question 1. Maybe I should switch this over to hard because there's a lot of steps. Let's move on to question 2. And we'll do this really quickly this time. Notice that this is cosine to the power of 3x. I'm going to break this down into cosine x, cosine squared x. This is sine to the power of 5x dx. This is the same thing as 1 minus sine squared x because of that identity that I showed you above. 1 minus sine squared x sine 5x dx. I'm doing this as fast as I can because I spent a lot of time on question 1. I'm going to set this as my u, where I have u is equal to sine x. This becomes du cosine x dx. So I'm going to replace these with u's and that dx with something else, where I have the integral of cosine x 1 minus u to the power of 2 u to the power of 5, and my dx is du over cosine x. This cancels out, and you're left with the integral of u to the power of 5 minus u to the power of 7. We're adding 2 and the 5 together, du. Finding the integral of this is easy. U to the power of 6 over 6 minus u to the power of 8 over 8 plus c. We get sine 6x over 6 minus sine to the power of 8x over 8 plus c. And this expression right here is the integral of this function. And there you have it. That is how to integrate trigonometric functions containing sine and cosine with odd powers. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.